First thing we're going to do is factor our denominator. Our numerator cannot be factored any more than it already is, so we'll leave that as 2x plus 3, and our denominator is going to factor into 3x and x, and then 2 and 3, and that's going to be plus and that's going to be minus. Okay, I think that looks good. And we don't have any wholes because there are no common factors that are going to cancel out in our numerator and denominator. Our vertical asymptotes are the undefined points in our function, so we're going to take our denominator and set those factors equal to 0. And then we're going to add 2, divide by 3, and over here we'll subtract 3. So we have x is equal to 2/3 and x is equal to -3. Horizontal asymptotes, you're going to compare your degree of your numerator to denominator. The degree of the numerator is less than the denominator. So that means y equals 0, or the x-axis is going to be your horizontal. That wipes out a slant. There is no slant. The zeros are the x-intercepts. So in order to find your x-intercepts when y is equal to 0, you take your numerator and you set it equal to 0. And so we are going to subtract 3 and divide by 2, so that's -1.5. And then the y-intercept is where x is equal to 0. So I'm going to look back at my original function and I'm going to plug a 0 in for my x's. It wipes out a whole bunch of terms, leaving me with 3 over -6, which is going to be -1/2. So when x is equal to 0, y is -1/2. And now we're ready to graph. And let's start with those vertical asymptotes. We are over at 2/3, which is less than 1. I know this is not exactly the best drawing, but it's hard to use these pens. Cat on the keyboard. Sorry about that. Okay, so let's go ahead and get my other asymptote in at -3. Oh, come on. And our horizontal asymptote is at y equals 0. I have a 0 at -1.5. So at -1.5, I put a 0 in there. And I have a y-intercept at 0, -1/2. And that's it. I don't have anything else to graph. So definitely I'm going to need myself quite a few extra points. So I'm going to go ahead and use my graphing calculator to help me out. You can substitute in all of your x values by hand and calculate them out by hand if you want, but there's quite a few ordered pairs that we're going to have to be finding here. So let's go ahead and let's do -2. So when x is -2, I am at 0.125, so I'm above the x-axis. Now that's obviously not 0.125, but my blocks are tiny and I drew my asymptote a little too high off the x-axis. So it's not quite in the right spot, but I'm just going to leave it there. And I'm going to go ahead and plug in negative 2.5. And I get 0.4. So at negative 2.5, I'm up 0.4, and I'm probably a little higher than I should be. But what that does tell me, at least, is that my graph is kind of creeping upward, and as it gets closer to this asymptote, it's going to get very high very quickly. And I know I don't have any more x-intercepts, so I'm not going to come back up and cross over the x-axis again, which means my graph, once I go from my 0 to my y-intercept, my x-intercept to my y-intercept, and I connect, my graph is going to continue to move downward. It's not going to swing back up and cross over that x-axis again. I'm going to try, I'm not going to graph it. Well, maybe I will. I'm going to try negative 2.75 and see what happens. I get a value of 1. How about negative 2.9? I get a value of 2.5. So at negative 2.9, I do get a value of 2.5. So I know I'm in the right direction. And I'm just going to go ahead and keep that graph where it is. It's going to be snug against that asymptote. I'm never going to cross that vertical asymptote. So it's just going to keep creeping closer and closer to it. Now I need to see what's happening to the left of negative 3 and to the right of 2/3. So let's go ahead and find a couple points over to the left. I'm going to substitute in a negative 4, and I get negative 0.3. So at negative 4, I am at negative 1/3. I'm like right here. Now I don't have any more x-intercepts. So by finding that one tiny little point, I can probably fill in the rest of my graph. I know what the rest of my graph is going to do. I'm never going to creep up and cross over that x-axis. I'm not going to be like swinging up past that x-axis. So my graph's going to be snug against this asymptote and never cross it. Otherwise, I'd have some zeros right there if I were crossing the x-axis. And then my graph is going to come down and hug this asymptote right here. Once again, you can't cross a vertical asymptote, and I don't have any more zeros to like creep back up. So just by finding one point in that region, because I don't have any more zeros and I have a vertical asymptote, I know what my graph's going to do. Now I'm going to go ahead and put in a 2. So when x is 2, I am at 1/3 or 0.35. So when I'm over 2, I'm up here at 1/3. That's probably a little higher than 1/3, but you can graph more precise if you have a nice pencil and you're not working with a tablet. You can probably do a better job at graphing. But anyway, once again, I kind of know what my graph's going to do. Because I don't have any more x-intercepts, it's not like my graph's going to swing down and cross back over. I know my graph, if it does anything, is just going to hug that asymptote and not go past it. If I were going to pass that horizontal asymptote, I would need an x-intercept over here, and I don't have any. Also, as my graph moves towards the left, it's never going to cross over that vertical asymptote, and it's not going to come back down because I don't have any more zeros. So just by knowing the fact that I have no more zeros on that x-axis, and knowing that I can't cross a vertical asymptote, I really don't have to find that many ordered pairs on the outer edges. I can if I want to, but I don't really have to. So even on the inside of the graph, I didn't really need to find all these extra points, even though I did. I guess I just wanted some more verification that it was in the right region, but I really didn't need all of those extra points. One extra ordered pair above the x-axis would be enough to tell me what my graph is actually doing.